All right, this video is to help you with the Desmos Unit 5, Lesson 8. This is our first activity diving into multiplication. Previously, you were practicing addition and subtraction. If you are still struggling with subtraction, I would recommend watching this Math Antics video because we are going to move on from adding and subtracting. And adding and subtracting negative numbers, moving left and right on the number line, will work for decimals and fractions as well. All right, so for Tuesday, you're going to go ahead and click on the link. I am Unit 5, Lesson 8. And this is the first question you see. So you'll notice there are 7 questions. First one says warm up, distance, rate, and time. So this whole thing is going to be about position, distance, rate, and time. Number 1, an airplane moves at a constant speed of 120 miles per hour. So I'm going to draw a picture. So 120 miles for 1 hour. It says per hour. And it's moving for 3 hours. How many miles does it go? So it wants to know how many miles it goes in 3 hours. So 1 hour, 2 hours, 3 hours. Well, we know that it says constant, so it's the same speed each time. So it's the same 120 every time. So the way we could find the miles, we could add these up. So we could add up all 3 of these miles, because remember, we just want miles, which is up here. These are the miles. I can add them all up, or something faster. It's 120, and I need 3 of them. So that's one way I could find the miles. So it gave me miles for 1 hour per hour. I needed 3 hours. I need 3 of them, so I can add 120 3 times or multiply. Again, it says show your work, so I'm showing you on the side what I'm looking for. You'll type your answer here. That was number 1. Number 2, a train moves at a constant speed. It doesn't tell me the constant speed, it just says a speed. It travels 6 miles. I'm going to write that down. 6 miles in 4 minutes. Actually, let's draw a picture. Let's draw a picture. 6 miles for 4 minutes. So let's draw, I'm just going to, again, there's no right way to draw a picture. I'm just showing you. This is 1 minute, 1 minute, 1 minute, there's 4 of them. So these 4 minutes. I drew 4 boxes. So the total is 6 miles for 4 minutes. What is the speed per miles per minute? So they want to know how many miles does it go in 1 minute. So if I cut this 6 into 4 pieces, what has to go in each box? So I know it's not 1, because if I put 1, that would be 4, not 6. So I need to cut this 6 into 4 pieces. Well, if this whole thing is 6, then half of it has to be 3, right? Because 3 plus 3 is 6. So if the whole thing is 6, half of it has to be 3. So this half has to be 3. This half has to be 3. So 3 miles in 2 minutes, because if I cut 4 in half, I get 2. I want to know for 1 minute. So I want to know 1 box. So I have to cut 3 in half again. Well, if I have $3 and I cut it in half, I know I get $1.50. Let's check if that works. 1.5 plus 1.5. Well, 1 plus 1 is 2. And then 0.5 plus 0.5 is another 1. So that works. So it looks like each little box is 1.5. So it's 1.5 miles per minute. So I can put 1.5 for my answer for number 2. So my answer, again, is 1.5 miles in 1 minute. I could have also done 6 divided by 4. So 6 cut into 4 pieces will give me 1. which is also written as 6/4. So these are written the same thing. So I could have also done that. But 1.5 or these work because I can write a decimal or a fraction. All right, so that's number 2. And then number 3, again, you're typing your answers here. It won't turn green until you have all of them correct. A car moves at a constant of 50 miles per hour. So I'm going to draw a picture again. 50 miles for 1 hour. It says, how many miles does it take the car to go 200 miles? Well, 2 of them would be 100. Whoops. And then that would be 150. And if I add another one, that would be 200. And so it looks like I took 1, 2, 3, 4. So it took that car 4 hours. So you type 4 for number 3. Another thing you could have done, you could have took the 200. Whoops. You could have took the 200 miles and divided it by 50. So either way, you will get 4. I just like drawing pictures. So 50 miles for 1 hour. So I need 4 of them to make 200. The answer is 4. All right, and I showed my work on this side. Your work doesn't have to look like mine. You could have done it without pictures. All right, feel free to pause. Again, this won't turn green until you have all 3 of them correct. So make sure you have a green check mark here and then click next. Number 2, it says read, then move to the next slide. So it's telling you that D equals RT. So distance, how far you go, equals your rate, which is your speed. And then when they're like this, it means multiply. So the time times how fast you go is the distance. So that should make sense to you. How far you are depends on how fast you go times how long you went. So how much time you spent running times how fast you go is where you will end up. So that should make sense to you. This is multiplication, by the way. We can write multiplication with a dot, with the times symbol, the times symbol, with the little star, which is shift 8, or with just parentheses or just next to each other. The equation D equals RT can be used to solve problems involving movement and constant speed. Distance traveled is your speed times the time. Multiply speed and time to find distance. Finding your speed is your distance divided by the time. So however you went the whole way, cut up by time will give you the speed. And then finding the time that's passed, you can divide your distance, how long you went, for how fast you went to find your speed. So they're all related. When you're done, you don't have to write anything on this one. I just notice the equation. And then go to number 3. Going left and going right. After each move, record your location in the table. Then write an expression to represent the ending position that uses starting position, speed, and the time. The first row is done for you. So notice that my starting position is 0. So it's 0 for all of them. So that means that my person is going to start at 0. So there's a number line here for you to visualize it. So my person starting at 0. The direction, right or left. So if my person's going to the right, it looks like these numbers are positive. If my person's going left, it looks like these are negative. So whenever it says left, I'm going to think negative. Right, I'm going to think positive. So I'm going to do that right now. Actually, I'll leave that like that. There we go. So just think right is negative. And they give me the speed, which is how far my person travels per second. So my person travels 5 steps per second, and he does that 3 times. So I'm going to show you on here. So he goes 5 steps, that's 1 second. 5 steps, that's 2 seconds. 5 steps, that's 3 seconds. So he went 5 steps every 3 seconds, and we end up at 15. We also ended up at 15 on my number line. So looks like we're multiplying how fast I go by how long I go for that time. Multiply. Notice my expression is 0, where I start, plus 5 times 3. So this 5 times 3, they're just writing it this form, but this means 5 times 3. So my expression is 0 plus 5 times 3. All right, let's do the next one. This time my person's going left 4 spaces, and he does that 6 times. So he's going left 4, that's 1, 4, 2, he goes 4 again, that's his third time. Remember, we're doing 6, 4, 4, 4. So 3, 4, 5, 6 seconds, and we'll end up at negative 24. So he's walking left, so he's going to end up at negative 24. The reason it's negative is because he was going left, so I'm going to put that negative on the 4. It wouldn't make sense to put it on the time because time is always going forward. We never go back in time. We always go forward in time. So I'm going to keep the 6 positive. I'm going to make the 4 the left. So I'm going to make 4 negative. All right, so my expression is going to look like this. 0, I started at 0. I went left 4 spaces, so negative 4. And I did that 6 times. And my answer was negative 24, because I ended up on the left. So my expression was 0 plus negative 4 times 6. Plus 0 plus negative 4 times 6. All right, so you're going to do that for all of these down here. So 0 plus, this time they're going right, 2 steps, 8 times. So 8 times 2 is 16, and my expression would be 0 plus 2 times 8. 0 plus 2 times 8. Next one, 0 plus, so I'm starting at 0 again, 0 plus, they're going to move 6 steps, and they're going to do that 2 times. So 0 plus 6 times 2. Again, just writing parentheses. You can also write a little star if you like to write that as your multiplication. And then 6 times 2 would be 12. Last one, 0 plus. This time I'm going left, so my person's going to the left, so I'm going to do negative 1.1. And so if he's going 1.1 to the left, 1.1, 1.1, 1. He's going to do that 5 times. He's going to end up on the left, and then 5 times 1 is 5. 5 times 1 is 5, so it's just 5.5. And my expression would be 0 plus negative 1.1, because he's going left. So 0 plus negative 1.1 times 5. So I'm going to put parentheses. You can also put a little star if you like to write your multiplication like that. All right, on to the next one. Feel free to go back and pause if you need to. Looking back at the previous slide, how can you see the direction of movement in your expression? So how do you know if your person's going right or left? What did we use to represent right and left? Well, we used right was a positive number, left was a negative number. So right here, you're going to type when the direction was right, I used a, when the direction was left, I used a, take a look at my picture. When I go right, I used this kind of number. When I go left, I used this kind of number. When you're done, click submit. For number 5, it just says read and move to the next slide. So we can talk about speed in a direction by calling it velocity and using signed numbers. So they're going to say negative. Negative numbers are going to be west. Positive numbers are going to be east. So still right And left, we're just throwing in east and west as well. So east won't always be positive. For this example, it will be. For number 6, it will be. So east is right or positive. Traveling west is going to be negative. Okay, so for number 6, it says velocity. A traffic safety engineer was studying travel patterns along a highway. She sets up a camera and records the speed and direction of cars and trucks that pass by the camera. Positions to the east of the camera are positive and west are negative. So we have like a little car, not the best car, but we have a car. We have cars. If the car is going east, that's going to be positive. If cars are going left, that's going to be negative, or west. West is left, east is right. All right. Vehicles are traveling towards the east are positive. Again, vehicles going west. So, we know that cars, there's 2 lanes, there's 2 different directions. Cars travel to the right are going to be east, and then the other lane is going west. So we know that cars travel different directions. Complete the table with the position of each vehicle. If the vehicle is traveling at a constant speed, indicate time period, then write an equation. So they're giving me the speed, so meters per second, and they're giving me how much time has went by. So notice that the time is always positive because time always goes forward. And they're giving me how many meters it goes for 1 second, and then I need this many of them. So this is 1 second, I need 10 of them. This is 1 second, I need 30 of them. This is 1 second, I need 40 of them. Of course I can add, but that would take forever, so multiplying is faster. So whenever they give me meters per second, and then this is the time, so this is the seconds, I'm going to multiply. So 25, and positive means this car was going to the east, so this car is going right, or the car is going left. So negative and positive. So this car is going 25 meters, and he does that 10 times. So this car is going right, and he continues to go right, and he ends up at 250 meters. My expression is just 25 times 10. So notice my expression is 25 times 10. That dot is the same as 25 times 10. And then that dot comes from doing the shift 8, the little asterisk symbol like this. These two are the same. Doesn't matter which way you write it. I'll show you on the next one. Negative 20 just means that this car is traveling west. So this car is traveling west 20 meters every second, and he does that 30 times. So he's traveling 20, 20, 20, 20, 20. And then he does that 30 times. So 20 times 30. 0, that's going to be pretty much a dead 0. 3 times 0, 3 times 2 is 6. So I get 600. And the car was going left, so if he continues to go left, he's just going to keep going left. So if it's negative, then he's still going to be at the negative position. So if the car is going west, he doesn't do anything crazy. He doesn't flip a U-turn or anything. So if he's traveling left, he's going to end going left. And the negative means left. And then notice my expression is going to be negative 20 times, I can use the shift 8, or I can use parentheses. This is positive 30. So I can put a plus there if I want, but we usually just don't put a sign on positive numbers. So negative 20 times 30. Or I can do negative 20 times 30, like that. So both of those are correct. So feel free to change the expression to see if it changes the, notice I can't put an X, but I can put a star, and I could put parentheses. So both of those work. All right, next one. 32 meters every 1 second and 40 seconds pass. So I'm going to multiply those two. Again, you can just stack them and multiply. So 0, that's just going to be a dead 0. 4 times 2, and then 4 times 3. I'll get my answer. I'll put it here. This car is going right because it's positive, so this answer is going to be positive. And then my expression is right here, 32 times 40. They're both positive, so I can just write 32 times 40, or I can write 32 parentheses 40. Next one, this car is going to the left, so negative 35. Negative 35 times 20. Again, I can stack them, 35 times 20, unless you know another way to do it. Should be practicing multiplication like this because you will not always have a calculator. This car is traveling left, so it is going to be negative because if the car is going left a bunch of times, he's still going to be on the left side. So this one the answer will be negative. So whatever you get when you multiply, just put a little negative to show that the car is going left. Again, my expression is negative 35 times 20. So you would write negative 35 times 20. And the last one, let's do orange. If I go 28 meters per second and no time has passed, my car is frozen. My car has not moved. Anything times 0 is 0, and this should make sense because it doesn't matter how fast I go. If there's no time, my car is frozen. And then my expression would just be 28 times 0. 28, I can do shift 8, or I can do parentheses. So if I want to do parentheses, I can do that too. All right, so feel free to pause. I'm going to scroll up though. Next question, if a car is traveling east, so if a car is traveling east to the right, when it passes the camera, will its position be positive or negative 60 seconds after it passes the camera? So if it's going east, and now it's gone east 60 times, if I multiply a positive number and a positive number, is my result positive or negative? So if we multiply two positive numbers, hopefully you notice up here, when I multiplied positive 25 and positive 10, I got a positive answer. So if my car is going left and he goes left multiple times, it's still positive. So your answer is positive. So positive times a positive is positive. Next question, if a car is going west, so if a car is going left, will its position be positive or negative 60 seconds after it passes the camera? So it's going left and it does that multiple times. Remember, again, just keep going left. So the question is, if we multiply a positive and a negative, will the answer be positive or negative? So notice right here, when we had a positive and a negative number, my answer was negative. So if my car is going left and time is positive, my car is continuing to go left. So my car is still going to the negative side. So you'll pick positive. So a positive times a positive is positive. We already know that because 5 times 5 is 25. Whoops. And a positive times a negative seems to be negative. That's what it seems to be right now. So multiplying two positives is positive, but when I throw in one negative in there, just one negative, I get negative. It makes sense because if the car is going left and he does that multiple times, he's still going left. All right, feel free to pause. I'm going to go to the last question. All right, checking for understanding. How can we represent a position to the left or to the right of a starting point without using direction words? So if I have a number line, how can I represent going left and right without words? Well, we use positive and negative numbers. So we use the direction left as negative and right as positive. So you would type that. And my second question, which you should also have a sentence for, remember we're using complete sentences. We're in 7th grade, we can use complete sentences. So we use left direction with negative numbers. We use right direction as positive numbers. Second question, what kind of numbers do you get when you multiply a negative and a positive? So same question kind of as the last one. When it's a negative and a positive number that are being multiplied, remember when a car is going left and time is going by, it's still going left. So a negative and a positive number is a negative number. So right here, you'll type, when you multiply a negative and a positive, we got negative numbers. That's what we got so far in our answers. So we're going to talk more about these kinds of rules, but for our example, when a car was going left and time was passing that was positive, the car was on the left side, so negative. So you'll type that in here. Again, complete sentences. When you're done, don't forget to mark it as done, and have a great rest of your day.